vector space. Now, please listen very carefully. What is vector space? Vector space is also a special set. It's a set. It's a set which satisfies certain conditions. Exactly the same way we gave a set, we took a set. See, look at this field. We took a field. Where is it? We took a set. It satisfied some conditions. We gave it a special name field. Same thing we are doing here. A set which satisfies certain conditions. We can call it vector space. Now, question is, then what is the difference between vector space and field? Vector space, listen carefully, elements of vector space are called vectors. Look at this, elements of vector space are vectors, not scalars. So what is the advantage of vector space? See, fields like I told you, you can have only numbers, nothing else. But vector space, you can have everything. Vector spaces can have anything, can have numbers, you can have only numbers. You can have matrices. You can have n tuples. So I think this word is, like, you know what n tuples is? N tuples is a collection of sets, numbers in one bracket. N tuples. You can have polynomials. Everything you can have. Any complex thing. And what you need to understand is elements of vector space. Elements of vector space are constructed from a field. Okay. See, for example, suppose I'm saying field is R, and I'm saying vector space is, just 1 minute. I'm saying vector space is 2 into 2 matrices. This means that suppose I'm having the 2 into 2 matrices. I should say A, B, C, D belongs to real numbers. That is field. See, you cannot have a vector space without a field. See, field is the basic building block for the vector space. What you are doing, you are taking all these scalars from the field and you are rearranging it in one separate fashion. In this vector space, you are arranging it as matrices. So what are fields? Field is a building block. Are you understanding how vector space and field is connected? Tell me, this clarity should have 100%. How vector space and field is connected. We are taking the elements from the field and we are building some special things like matrices, or we can build polynomial in the vector space. Okay, is there any confusion in this? Can I go to conditions of vector space? Yeah, Gautam, one of your response.
Okay.
Yeah, we can go. Very good.
It is clear, bro.
Very clear. Very happy. So now we will see conditions a vector space for a set to qualify as a vector space B over a field. Yes, when you are talking about vector space, you should have a field because that field is the basic building component. Vector space is the complex structure you have created from the field. So you cannot just say vector space. Always when you're talking vector space, you need to talk about the field from which it is being built. Okay. Now what we are doing, first we will be defining two things. Listen carefully. First we'll take two definitions. First definition I am taking, I am defining plus, that is addition operation. Listen carefully. This plus operation, I will take one vector from V and I will perform the operation on another vector, and the resultant I will get a vector. Definitely you won't have understood this, so please wait. I will, when I'm showing example, it will be pakka clear. The way you have to wait. Okay, this is a notation which I'm writing. Then I am defining multiplication. When I'm doing multiplication, I am taking one element from the field, I am taking another element from vector space. The result should be part of vector space. Definitely you would have understood. First you just see these notations, be familiar with them. I'm doing examples, you'll understand. When I'm doing writing the conditions and doing examples, it will be pakka clear. So conditions I'll write. First condition is A plus B. I forgot to define what it is. A, B and C. No, not right, I'll write vector. Vector 1, vector 2, vector 3 belong to vector space. Okay. K1 and K2 belong to field. See, listen very carefully. These are vectors. See, vectors means please don't think of vectors. They are not like IJ, cannot like that. Vectors can be anything. Can be matrix. Matrix is a vector. Can be polynomial. That is a vector. Okay. And these are scalars. Scalars are only numbers. We are taking 3 vectors and 2 scalars. So now what I'm doing is, first condition is I should have associativity. I'll write normal order, I'll write commutativity first. I should have commutativity. That is, I should have vector 1 plus vector 2 should be equal to vector 2 plus vector 1, and the resultant should be a vector. When you're adding both vectors, you should get another vector which is a part of vector. So commutativity and closure, I'll write both together. Okay. Second property is we need to have associativity. You will have V1 plus V2 plus V3 should be equal to V1 plus V2 plus V3. Third properties you should have, for all you should have identity element, not like that. You should have identity. Zero, such that V1 plus 0 is equal to 0 plus V1 equal to V1. And fourth, you should have inverse. You should have additive inverse. Now I'm talking about addition, don't talk about multiplication. Additive inverse. So you should have V1 plus inverse. Sorry. Additive inverse is V1 plus inverse equal to inverse plus V1 equal to 0. Meaning I should have D, I should have as minus V1. This should be a part of the field. Definitely some confusion will be there. First I'll write all the properties, then I'll give you, when I'm discussing examples, all of you can interact and it will be very nice. So now I'll do multiplication properties. Listen carefully. Please observe one time this slide. When I'm performing, these 4 properties are belonging to addition. Okay. When I am performing properties for addition, I am taking one element from vector space, another element from vector space. I am not even talking about the field. See, I'm taking one element from vector space, I'm taking another element from vector space, and I'm checking is the result also in vector space. Is it clear? We are not talking anything about field. In addition operations, one element from vector space, another element from vector space, result should be in vector space. Now, but if you're talking about multiplication, we will take one element from the field, another element from vector space, and check if the result is in vector space. 1 minute, I will explain. So if you're seeing fifth property, We can say I've taken K1 into V1 plus V2. This should be equal to K1 V1 plus K2 V2. This is nothing but distributivity. And this should belong to the vector space. Sixth property is I'm having
K1 V2, right?
Yeah, sorry. Yeah, sorry. Sorry. Next we'll have K1 K2 times V1 should be equal to K1 into K2 V1. This should be equal to K2 into K1 V1. I hope this is clear. You're just taking it outside. You should be able to group it. This is grouping property. You can take it like that. Okay. Seventh property is you need to have multiplicative identity. That is 1 into V1 should be V1. Final property is you need to have K1 plus K2 into V1 equal to K1 V1 plus K2 V1. Okay, see, listen carefully. These are all scale. This is all scalar. This belongs to field. This belongs to vector space. You understand all these things you should understand. Okay. So definitely at least 50% I hope you understood. At least 50% you understood.
Fullave purinjadu bro.
Fullave purinjadu. Very good example. This because you've already seen examples. Okay. Otherwise you have seen for first time. It will be good. Anyway, I'm happy. If you're 100% you understood now itself, it's I'm very happy. See, what you need to understand this is, see, I am taking one operation from, I'm taking one from field and I'm taking vector from vector space. See, that is what I wrote initially. One element from field, another from vector space. The result should be addition. I will take two vectors from vector space and check addition. But for multiplication, see, for multiplication, don't take two vectors. You cannot take two vectors for multiplication. For multiplication, you will take a scalar from field and vector from vector space, and that you will check multiplication. Okay. So if all elements are satisfied, if all 8 conditions are satisfied, then what should you say? V is a vector space. You shouldn't, that's not enough. You need to say V is a vector space over field F, because field F is the building block. Vector space is the complex thing that you have created. V is the field is a building block. Okay. Now, yeah, if you have understood fully anyway, and how you will write notation is you can write notation like this: V of F, comma plus comma, like this you will write. Okay. Now we'll take some examples. Okay. Verify if the sets are vectors there over the given fields. Look at this carefully. First question I'm giving. I'm taking vector spaces real numbers. I'm taking field also real numbers. Please try it and tell me. Take vector space also as real numbers. Take field also as real numbers. And tell me if V is a vector space over F. Yeah, just waiting for answer. We'll be doing how many examples?
Yes.
Yes, it is a vector space, correct? See, I want to explain this in detail, okay? Because I have many other better examples to explain in more depth. So, if for this example, I think you can do it yourself, okay? You can say R is a vector space over R. We can say, okay? Some other examples we will do. that time I will write and show in detail. So second, I can take, suppose I'm taking vector space as R and field as Q. That is rational numbers. If you don't know, Q means rational numbers. Please verify if this is a vector space or not. Right, next example also. That example, we will reverse it. We will take vector space as Q and we'll take field as real numbers. Just two examples, do it. As we keep proceeding, clarity will become better and better. Initially, clarity will not be there. Slowly, it will become better and better. Don't worry. Remember, field is a building block. Vector space is the things we are constructing from the building block.
I think second one is yes and the third one is not.
Excellent. Who told this answer?
Yogeshwaran.
Very good, very good. Your answer is Pakka, okay? Pakka answer. Second is a vector space, but third is not a vector space. See, second vector space, please try it yourself. Third question, we will try to understand, okay? Why it's not a vector space. I will give proper explanation. So if you are seeing first property is first four properties are related to addition, and first four properties we only have to bother vector space. We don't even have to worry about field, correct? Only inside vector space we will work out. And if you observe, if you sit and do the calculations, if you sit and do all the results, you can say that first property is satisfied, second is satisfied, third is satisfied, all four will be satisfied, correct? And multiplication we have to define it from field to vector space, and there should be in field vector space. These properties we will see. So what is first property? What is fifth property? Fifth property states we will take one element from field. See, we will take v1, v2, v3 belongs to vector space, and k1, k2 belongs to field. Okay. And now if you are trying to check the properties, fifth property, k1 into v1 plus v2 should be equal to k1 v1 plus k1 v2. But thing is that this result should be a part of vector space. This result should be a part of vector space. This result is not going to be true. See, let me take v1 as rational number q. I'll take v2 as another rational number. But k1, listen carefully, k1 is a field. Field, I am free to take anything, correct? These are from vector spaces. These are from vector space. These were from field. So from field I can take anything because field is real numbers. Now if I am multiplying and seeing k1 into v1 plus v2, this will be 3 root 3. This is not a part of vector space. Doesn't belong to vector space. So I can conclude that third question is not a vector space. See, you cannot say Q is not a vector space. You should say Q is not a vector space over R. Okay. I hope this is clear. Any doubt, please ask. If one property is not satisfying, then there is no point in checking. We can just conclude that it is not a vector space over the given field. Okay. Hope it is clear. Any doubt, you can stop me and ask. Fourth question. I'll give two questions, do it, and I'll give field also as Q. Next I will give I will give as R squared and I will give field as R. Please do these two questions. This is R squared. Please do these two questions. I want answer from somebody.
R square na another?
R square now we are taking n tuple. I'll explain this question. I will give explanation. For this question, please tell the answer.
அது வந்து vector space. Fourth one is
First one is vector space.
First one definitely is a vector. You should not say vector space. Don't tell like that. You should tell it is a
vector space over field.
Over the field. Very good. Okay.
Q.
So before coming to fifth question, if you are doing some observations, look at this carefully. Look at first question. Okay. And you look at this question. Okay. Like that, I can frame many questions. What is the similarity between first and second question? Is you are having QQ. Here you are having RR. Okay. So one conclusion we can do, write it as a note. Every field is a vector space over itself. That is, if you are taking field and vector space as the same, definitely it will be a vector space. No doubt. Okay. You can take it as a property. You don't have to, if you want, you can remember it. Otherwise, in the question, see, listen carefully. This is a complete theoretical chapter. All these steps, see, I wrote like this, right? 1, 2, 3, 4, 5, and it cross tick. In the examination, you need to prove everything, tick properly and show. Meaning you should prove associativity, you should prove like that. You just, that's it. This chapter is full of that only. There is no numerical, nothing. This is a more theoretical chapter. Okay. Now we will try to understand this fifth subdivision. Okay. So Gautam asked what is the R squared. Okay. So what is R squared? R squared is the 2D plane. But it's not properly, we need to understand how it's defined. Field is real numbers, it is very clear. Now what is that? Now we need to see what did I tell you? I told you field is building block, and we something we are building using real numbers. What are we building? We are building n tuples. R squared means we are building 2 tuples. Like this, it will be as x comma y, such that x and y both belong to real space. Is it clear? So what we are doing, we are taking the building block real numbers and we are putting bracket like this. We are putting comma in between. We are writing 2 real numbers and we are enclosing it inside one set, and we are calling this as one vector. Because elements of vector space are known as vectors. Any doubt on this? So first you should understand what the vector space is. Vector space is a collection of all such things. You will have many such collections. This is the vector. This is the set, not vector space. I have not yet confirmed whether it's a vector space. We will verify whether it's a vector space. Okay. How to verify it's a vector space? We will see it. Let v1 be x1 y1 and v2 be x2 y2. We'll take no. We have to take 3 vectors, correct? We'll take 3 vectors. Always remember, for vector you take 3 vectors. Scalar you take 2 scalars. And I'll take alpha comma beta belongs to R. Okay. All these 3 belong to R squared. That is field. Sorry, vector space. This belongs to the field. So we need to check all the properties, correct? But before checking the properties, we need to define what we are exactly doing. See, suppose what I'm telling is, first I'll define plus symbol. Plus symbol is defined like this: x1 comma y1 plus x2 comma y2 means I am giving. See, listen carefully. This is normal addition, correct? Today, ma'am did many questions wherein they gave their own definitions. In the question, suppose I am only giving this much, verify this. Then what you will assume is, you will assume that it is normal addition, normal multiplication. Okay, you need to assume. But sometimes what they will do, they will tell check whether it's a vector space when plus and dot are defined as follows. They'll write like that and they will give their own definitions. That time the definition will change. I will do one question like that also. First we will see normal. Normally suppose it's defined. So normally I'll define alpha into x1 comma y1 as alpha x1 comma alpha y1. Okay. Now we will see the properties whether it's getting satisfied. You can see first property. What is first property? First property is closure. Commutativity is obviously 2, right? This if you add with this if you add with it's 2 and not more waste time writing all that. First is satisfied. Second property, associativity, that is also obviously satisfied, correct? Whatever order you add, it's associative satisfied. Third, what is third? Third is identity, correct? Third is identity. Now you tell me what is identity element? Identity, I need to have vector 1 plus 0. I need to have 0 plus vector 1. This should be equal to vector 1. So not 0, I won't write 0, I'll write E. Vector E, identity vector, equal to identity vector plus V1 equal to V1. This I'll call as identity vector. Additive identity vector. Now obviously look at this, I'll take these two equations. What I'll do is I'll write V1 is x1 comma y1 and identity vector I don't know. This will be equal to x1 comma y1. So I can say identity vector is 0 comma 0. Now my question is 0 comma 0 present in the vector space? Is it that? Is this element a part of this vector space? Can someone tell me yes or no? I want an answer, yes or no?
Yes.
Can you have 0 comma 0?
Yes.
Is because x, this is there, no, x and y belong to real. We mean it is there. It is part of vector space. So this condition, third condition, is satisfied. This is all you have to check. The identity vector what you are getting, is it there in the vector space? If it is there, the third condition is satisfied. Okay, I hope it is clear. Now fourth condition is we need to check presence of additive inverse. We'll check additive inverse. How to check additive inverse? So I need to have V1 plus V inverse, sorry, plus 1 here, plus 1 equal to V inverse plus V1. This should be equal to V additive identity, correct? And this we just show it as 0 0, correct? Now we will see V1 is x1 comma y1. This if we are adding with the additive inverse, we should get 0 comma 0. So obviously we can say that V inverse will be minus x1 comma minus y1. Now tell me, for whatever x1 y1, will this inverse exist in the vector space? Is there any situation that we are having x1 comma y1 but we don't have this? Is there any such situation? Think. Any such situation? Tell me. We're having x1 comma y1 but we don't have x2, we don't have minus x1 comma y1. Is it there? Is it there or not?
No,
It's
no.
not there. Not there.
No, it's not there. Yeah, it's not. There's no such condition. This always is about a vector space, so there's no problem. So fourth condition is satisfied. Okay. You should think like this. I'm just telling you how you should think. That inverse, there should be any xy you take minus xy should be there. That you should verify. Okay. Fifth property, if you are taking, we can take what is the property? And I am forgetting all the properties. So what is the property? Alpha into V1 plus V2. Is it equal to alpha? Now what is it? This should be equal. So if you are taking LHS is alpha into V1 is x1 comma y1 plus x2 comma y2. And look at this carefully. We have defined this operation like this. Based on how we have defined only we should do. So based on we have defined like this. So I'll write alpha into x1 plus x2 comma y1 plus y2. And we have defined multiplication like this. So just like how we have defined multiplication, I am expanding alpha x1 plus alpha x2 comma alpha y1 plus alpha y2. See, I am actually showing a presentation. In exam, you will present like this only. You will write LHS equal to like this. Now RHS you will write. RHS is what? alpha v1 plus alpha v2. What is alpha v1? Alpha x1 comma alpha y1 plus alpha x2 comma alpha y2. This will be equal to what? Alpha x1 plus alpha x2 comma alpha y1 plus alpha y2, correct? So can I say LHS is equal to RHS? So can I say fifth property, it is satisfied? Out on this fifth property. See, I'm just showing you one by one how you will present in the exam, how each property will verify properly. Okay. So if you take sixth property is just grouping, correct? Alpha beta into v1 should be equal to alpha into beta v1 equal to beta into alpha v1. You do it yourself, okay? You just need to prove all these things. You can just, it's very obvious that this property is going to get satisfied. Okay, I'm leaving it to you. Seventh question is, we need to check 1 into v1, is it v1? Now this property I'll explain properly. We need to check, is 1 there in the field? Are you having any such thing? Such that 1, it is there in the field, correct? Because only if 1 is there in the field, we can even call it a field. So 1 into v1 is what? What is 1 into v1? 1 into x1 y1, and according to multiplication we need to multiply 1 into x1 comma 1 into y1. This will be equal to x1 comma y1. This is equal to v1. So this property is satisfied. If we take property 8, that's all. The question in exam will be like this only. V is equal to v with respect to normal addition multiplication. Check whether it's a vector space or not. That's it. 5-mark question. I think you will write all the properties like this and you will show all properties are satisfied. That's it. So no need to worry at all. So I'm having alpha plus beta into v1 should be equal to alpha v1 plus beta v1. What we can do for this also exponential. What is LHS? LHS is alpha plus beta into v1. What is it equal to? Alpha plus what is v1? v1 is x1 comma y1. So I can say alpha x1 alpha plus beta of x1 comma alpha plus beta times of y1, and I can say RHS is equal to alpha v1 plus beta v1. Alpha v1 means alpha into x1 comma y1, beta into x1 comma y1. This will be alpha x1 comma alpha. No step you should miss. You can't miss any step. All steps are important. Beta x1 comma beta y1. Next step only you will write is equal to alpha x1 plus beta x1 alpha y1. Even if it is very obvious, all steps should be very clear. Alpha plus beta into x1, alpha plus beta into y1. So I can say LHS is equal to RHS. I can say property 8 is satisfied. Are you understanding how to present, how everything is clear? Hope it's clear. Huh? Tell me.
Clear.
Yes. So then, as all conditions are satisfied, all 8 conditions are satisfied, I can say R squared is a vector space over R. That's it. This is all. As all 8 conditions satisfied, I can say R squared is a vector space over R. Okay. So now, just think about this statement, what I'm writing. I'm going to write a statement. You will think about it. What a statement is. Give me 1 minute. Where is it? Note, R power n is always a vector space over R. With respect to normal plus n operation definitions and Rn are n tuples. Okay, See, it's not just r squared. See, imagine I'm extending v1 as I'm writing for r cube, I'm going to x1, y1, z1. I can even go to r power 4, I can go to w1, x1, y1, z1. Any number of dimension I can go. It is still all properties exact same way to be satisfied. Correct? Am I right? So there is going to be no problem.
Yes.
R power n any, and this is n tuple. See, this is no n tuple. I think this word only many people I think they had confusion. N tuple and n tuple na, that's it. This is x1 comma, that's it. This is one n tuple, that's it. Okay. Note on this. Now I will give another example. Not just for r power n, I will generalize it better. Any field power n, it's not just r power n. You can take q power n and q, field power n and field. Okay. You can take anything, but it should be, you can't, I'll ask you one question. Someone tell me. Okay. Suppose I'm taking z power n, I'm taking vector space z power n, and taking field as z. Is V a vector space over field f? Someone tell me this question answer.
Yeah.
Z itself is not a field, no.
Appa, this is what I was expecting. Z itself not field, then how will talk about vector space? Field itself is wrong. You should be careful, okay? First of all, it should be a field. If it is field, then we will talk about vector space, okay? Okay. Now, which question number we are in? 6. Sixth question, I am not doing it because it's taking a lot of time. Sixth question. Taking vector space as complex numbers and I'm taking field as real numbers. Okay. See, even this is, you can think like building block. Suppose I am listening carefully. I am defining vector 1 as a1 plus ib1. Vector 2 as a2 plus ib2. Vector 3 as a3 plus ib3. What are the building blocks? Building blocks are what? All the A's, that is A1, A2, B1, B2, B3, everything. All this belong to field R. Okay. This is pakka definition of pakka example of vector space. How I'm showing you how it's a building block. Okay. And how will you define addition? You need to define addition properly, correct? How will you define addition? You take V cross V, it will go to V. How? Suppose I'm saying V1 plus V2 will be A1 plus A2 plus I into B1 plus B2. This is how you're defining, correct? And you will define this from like this, such that alpha into V1 will be alpha A1 plus I into alpha A2. And I'm saying alpha comma beta belongs to R. So this is how we are defining the operations. Then you will verify all the 8 properties and you can say that definitely this is a vector space. I am telling you, I am not going to sit and prove. One question I sat and did elaborately. I think you can try to do it for other properties. For 6th question, you try to do it on your own. Okay, all 8 properties you sit and verify. Definitely you will be able to get the answer. Okay. Now we will do 7th. I'll finish at 6 o'clock. Okay, on 10 more minutes I will take. 6 o'clock I will finish the class. So I will take a 7th example. I'm giving V as I'm giving as all M into N matrices. Okay, all M into N matrices, and field I am giving as real numbers. Okay, so we will see whether it is a vector space or not. Now, when I'm saying all M into N matrices, I should say all elements of matrix must belong to R, that is field, correct? Because field is building block. Again I'm saying that, and I'm defining plus how. Now first I'll write AB definitions. Let A, B, C belong to vector space, and let B, let okay, ABC belong to vector space, and alpha comma beta belong to field R. Okay. So how I'll define A like this? It will be A1, it will be A1, A2, like this. Keep on going. We don't know how many dimensions, M into N, correct? B will be B1, B2, how much ever. Keeps on going. C will be C1, C2. Okay. And how we'll define addition? We'll define it as add corresponding elements. Correct? I'm not writing the full definition. Suppose I'm saying A plus B, what you will do? You will add this. That's it. And I'm doing multiplication. Multiply all elements of matrix by scalar. Right? Now you will check all the 8 properties. You just think first property, what is will be? I'll just explain. I won't write everything. I'll just explain without writing. So we'll check all the 8 properties. What is first property? First property is it should be closed. Suppose you're adding 2 matrices. That also will be a real matrix, correct? Is it possible you're adding 2 matrices but you're getting complex matrix? It's not possible, right? 2 real matrices adding real matrix only. Then commutativity, if you're adding A1 plus B1, B1 plus A1, same thing. So this first property is satisfied. Now second property is you need to have associativity. You're doing this, whatever order you're adding, it's going to be same. Satisfied. Third property is you should have 0 matrix, correct? Identity matrix. What is identity matrix? I can have a matrix like this, no? 0, 0, 0, a full 0. It's there or not? It is there, right? If you're adding, if you're putting A plus this 0 matrix, we will get A only. So we are having identity element here. And are we having inverse element? We are having inverse element. I can have inverse element as, you know, I can have minus A1, minus A2, everything inverse. Then if I'm adding both, I'll get 0. So these 4 properties are satisfied. Now fifth property is this distributivity. All the properties will definitely get satisfied. I don't need to check. Distributivity you check. It will get satisfied. Grouping it will get satisfied. What else is there? 1 is there. 8th properties. What is the 8th property? Alpha into V1 plus V2, that property. Alpha plus beta into V1, that will get satisfied. Does anyone have any doubt on this? Like, do you want me to, if you want me to elaborate any one property, I'll be very happy to do it. But you can try it on your own. Then, does anyone want me to explain any one of these properties? I will explain. Otherwise, we'll proceed. Hello? Someone tell me. Clear? No need any explanation. All properties are clear.
All are clear.
Not clear. Okay. So. Okay, so I think I've given enough examples. What I'll do is I'll keep one more class. In that class, what I'll do is I will solve all the questions which ma'am has given in her sheet. Today I've discussed all the basics. I will give all the questions. Next class I will discuss all the questions which ma'am has given in the sheet. Then we will get another better set of clarity we will get. Okay. Today's class I have taught what is field. I have taught what is vector space and I have given a lot of examples. Okay, you can go and see. And I am seeing some people join now. Now only they joined. From the middle, I think they have joined. Not a problem. Class has been recorded, so you can sit and see the class. Okay, if you have missed any portion. Okay. So, yeah, Gautam, you can stop recording, or I'll stop recording.
Okay.